Good afternoon, students, and welcome to another video where we are going to start talking about something that's a little bit unique to our class. This is something that's not really typically talked about in sixth grade math. It's typically not talked about until eighth grade, but we're going to talk about something called radicals, which is the opposite of taking an exponent. So we're going to look at two specific examples. So if this is your second time watching the video, go ahead and take a pause and copy what you see down on the screen. Okay, so you'll notice at the top of the page, we have two exponents. We have 5 to the power of 2 and 4 to the power of 3, okay? Anytime we have an exponent to the power of 2 and anytime we have an exponent to the power of 3, they have their own unique specific names. Now, for the sake of this video, I'm going to use two different colors to represent to the power of 2 and to the power of 3. I have like a maroon and a burnt orange. I picked these colors because they kind of represent my school that I went to, A&M versus UT, because long ago they used to be rivals and they might likely become rivals again because I think UT is going to move to the same sports conference as A&M, in case you care about any of that. So I'm going to use maroon to represent anything to the power of 2 and burnt orange to represent anything to the power of 3. If you like color coding, you might want to use two different colors as well. If that's not something that you care about, then you can continue writing in the same color. So anyways, when we have something to the power of 2, this is another way of saying something squared. So another way of saying 5 to the power of 2 is I could say 5 squared. And when we take something to the power of 3, another way that we can phrase this is something cubed, something cubed. So instead of 4 to the power of 3, we could say 4 cubed. So when we talk about the opposite, we are talking about, okay, if 5 squared or 5 to the power of 2 is 5 times 5, the opposite, we're trying to figure out how can we like undo an exponent? We do something called a square root. And the symbol looks like this. You may have seen it before. It looks very, very similar to a long division symbol, except it kind of has like a check mark here at the front. This is called the square root symbol. And we're going to focus on square roots right now, and then we'll come over here to the cubed section. So when you see the symbol, this is the square root. So 5 squared is equal to 25, right? Because 5 times 5 is 25. So let's say they give us a number like 25 and they want us to find the square root of 5. So you'll see it kind of listed like this, where 25 is inside the square root symbol. And what this is asking you to do is to figure out what times itself makes 25. When we find the square root or any root of a number, even when we talk about cubed roots in a second, we're trying to figure out what number, when we multiply it times itself, makes a certain number. So if we're trying to find the square root of 25, we're trying to figure out what number times itself makes 25. And the answer to that is 5, right? 5 times 5 makes 25. So the square root of 25 is equivalent to 5. However, we have also been working with integer rules. So there's something else that happens when we are talking about square roots. Do you guys agree that -5 times -5 also equals positive 25? It should, right? A negative times a negative is a positive. So when we take the square root of a number, our answer can either be the positive or negative version of that number. So I'm going to put like kind of a big star over here so you can kind of like, when you refer back to your notes, know that this is like important. So the square root of 25 can be equal to positive 5, but it could also be equal to negative 5. So you'll see this symbol plus or minus. So we would say the square root of 25 is plus or minus negative 5, because 5 times 5 equals 25. And -5 times -5 equals 25. So when we take the square root, our answer can be positive or negative. So I'm just going to put that down here at the very bottom, positive or negative. It could be the positive or negative version of that number. So you'll see in the practice questions a couple of other examples. When we take the square root of a number, the examples that I'm going to be showing you are going to be what are called perfect squares, meaning there is a unique number when we multiply it times itself that will make is whatever's in the square root like section or in the square root problem. However, there's a way that if it's not a number, like let's say it's find the square root of 30. Well, there's not a number times itself that makes 30 an integer at least. So I'm going to show you guys a way that we can what's called simplify the radicals. We're going to talk about that at the end of the year. We're not going to get into that right now. So when we take the square root, we're basically doing the opposite of finding the exponent. So if 5 squared is equal to 25, the square root of 25 is what do we square to make that particular number. Okay. And along the same lines, now we're going to talk about cubed roots. So when we take a number cubed, the opposite is we're going to do something called a cubed root, and it looks like the square root symbol, but we keep this like little exponent 3. We just kind of stick it right here inside the check mark. So this is what's called a cubed root. And what a cubed root is asking us, let's say let's find the cube root of 64. It's asking us what times itself thrice or 3 times makes 64. And in 64's case, if we take 4 times 4 times 4, that is equivalent to 64. So we would say the cubed root of 64 is equal to 4, because 4 cubed up here is equal to 64. Okay. And you'll notice here, if we threw in negatives, right, that wouldn't necessarily mean that our answer over here is negative. So the rule when it comes to integers with cubed roots is the answer is positive if the cubed root's positive. So I'll say positive if positive. And then the opposite's true, negative if negative. And let me show you an example so you can see what I mean, okay? So let's say we want to find the cubed root of 8, okay? So what times itself 3 times makes 8? So the cubed root of 8 is actually 2, because 2 times 2 times 2 all makes 8. Okay. However, if I wanted to find the cubed root of negative 8, okay, this ends up being negative 2, because negative 2 times negative 2 times negative 2 is equal to negative 8, right? Negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. So if you're asked to find a negative cubed root, then you know your answer will be the negative version of that number. And then if you're asked to find a positive, the answer will be a positive. So again, cubed roots are asking us to find what number cubed makes the number that's inside of the cubed root symbol. So this is kind of the opposite of exponents. These little rules about positives and negatives can be a little bit tricky. So you may want to watch this video potentially for a 3rd time, at least to understand those rules. If this is your 2nd time watching the video, I am going to go ahead and show you guys the practice problems. Okay, you only have 4 practice problems today. Go ahead and take a pause and copy them down in your notebook. All right, so the practice questions are: find the square root of 900, find the square root of 169, find the cubed root of -27, and find the cubed root of 1000. If you have any questions or need clarification, please make sure you write it in the top part of your notebook. And as always, I hope you guys have an awesome day, and I will see you very, very soon.